Die US-Raumfähre Discovery soll heute zu ihrem letzten Flug ins All starten und es sieht tatsächlich so aus, als könnte es diesmal klappen. Die Wettervorhersage für den Weltraumbahnhof Cape Canaveral ist gut und es gibt laut NASA keine bedeutenden technischen Probleme. Der Flug musste bereits mehrfach verschoben werden.
Sicherlich, es ist schon etwas in die Jahre gekommen. Doch bis vor kurzem galt das Space Shuttle als die modernste Art, in den Weltraum zu reisen. Seit etwa 30 Jahren befördert es Menschen und Maschinen an den teuersten Arbeitsplatz und möglichst auch wieder zurück. Vorher ging das nur mit Raumkapseln und Raketen. Damit haben die Amerikaner zwar den Wettlauf zum Mond gewonnen, aber Raketen und Kapseln ließen sich nur einmal nutzen. Aus Kostengründen wurde darum Anfang der 70er Jahre der wiederverwendbare Raumgleiter entwickelt. Und der greift bis heute auf bewährte Technik der Apollo-Zeit zurück. Neben dem Raketenantrieb ist das auch der Starttisch. Der aber lässt sich nicht in die gewünschte Richtung drehen, sondern ist immer noch starr. Und genau das ist der Grund, warum das Shuttle während des Starts einige Tricks braucht, um auf den richtigen Kurs zu kommen.
2, 1 and 0 and liftoff of Space Shuttle Atlantis.
So muss sich das Shuttle nach den ersten 100 Metern drehen, um in die vorausberechnete Umlaufbahn zu gelangen. Gleichzeitig sorgt dieses Manöver für weniger Spritverbrauch. Mit optimaler Schubkraft und unterstützt durch die Erdrotation treibt das Shuttle auf der Umlaufbahn seinem Ziel entgegen. Der erforderliche Winkel für die Drehung wird in Bezug zum Äquator berechnet. So ist die Umlaufbahn der ISS beispielsweise um etwa 52 Grad gegenüber der Äquatorebene geneigt. Nach etwa 2 Minuten hat das Shuttle eine Höhe von etwa 45 Kilometern erreicht. Noch einmal dreht es sich, um schließlich ganz auf dem Rücken zu liegen. Das soll den extremen dynamischen Druckbelastungen entgegenwirken, denn nicht nur die Erdanziehung wirkt auf das System Space Shuttle, auch die umströmende Luft. Ohne diese Drehung würde das Shuttle auf den Tank gepresst werden. Die Verstrebungen zum externen Tank würden dieser Belastung nicht lange standhalten und schließlich brechen. Kein Tank, kein Treibstoff, keine Schubkraft und damit keine Mission. Anders, wenn es auf dem Rücken fliegt. So wirkt sein Gewicht gegen den Druck der umströmenden Luft. Die Verstrebungen werden entlastet. Im Übrigen hilft diese sogenannte Head-Down-Position auch bei der Kommunikation. Lästige Störungen, die durch den Raumgleiter selbst entstehen, werden vermieden. Darüber hinaus hat es auch einen psychologischen Effekt für die Astronauten. Die können den Horizont sehen und sich so besser orientieren, falls die Mission abgebrochen werden muss. Das Space Shuttle ist bis heute das einzige wiederverwendbare Raumfahrzeug, das je im regelmäßigen Einsatz stand. Alles begann 1981, als das erste Shuttle, die Columbia, zu ihrem Jungfernflug startete. Über 130 weitere Starts mit 5 weiteren Raumgleitern folgten. Doch trotz hochmoderner Technik, die Risiken eines Shuttlefluges sind größer als die mit einer Raumkapsel. Vor allem die Hitzeschilder für den Wiedereintritt in die Erdatmosphäre sind stark gefährdet. Sie liegen während der gesamten Mission offen und sind somit anfällig für Beschädigungen durch Weltraummüll oder Kleinstmeteoriten. Ein Loch in einer der Hitzeschutzplatten an der Nase war schuld am Unglück der Columbia. Heiße Gase drangen in das Innere der Raumfähre und zerstörten sie. Aufgrund dieser technischen Risiken und Kosten von etwa einer halben Milliarde US-Dollar für Wartung und Start wird das Space Shuttle nun ausgemustert. Über ein Nachfolgeprogramm ist bisher noch nicht entschieden und so steht Zukunft für die amerikanische Raumfahrt derzeit sprichwörtlich in den Sternen.
Space Shuttle Discovery, the venerable atop Launch Pad 39A here at NASA's Kennedy Space Center in Florida. Her wings outstretched and ready to soar into space for the 39th and final time. Shuttle Discovery is completing 27 years of service, the oldest space shuttle in the fleet, launching for the first time in August 1984 on mission 41D. And over the years, Discovery has achieved many notable accomplishments. In total, Discovery has spent 351 days in orbit, to be exact, 8,441 hours, 50 minutes, and 41 seconds. Orbited Earth 5,628 times, flown 246 crew members to date, docked to the Mir space station once, and to the International Space Station 12 times, with the 13th time upcoming. About 3.5 miles away from Discovery, launch controllers here in Kennedy's Launch Control Center Firing Room 4 are overseeing all the shuttle systems and verifying the step-by-step processes that will lead to an expected liftoff at 4:50 and 27 seconds p.m. Eastern Standard Time. Once again, at this point, there are no technical issues that stand in the way of today's launch. And we're going to take a look at the crew suiting up, preparing for today's launch of Discovery on STS-133. And we're seeing Commander Steve Lindsay with one of the suit technicians assisting him into his ACES suit, or his launch and entry suit. Pilot Eric Bowe, he flew on STS-126. He is our pilot today. He's logged over 4,000 hours in 45 different aircraft. This is Alvin Drew, Mission Specialist 1. He's a colonel in the Air Force. Once again, we have an all-veteran crew. Alvin Drew flew on STS-118. He'll be one of our 2 spacewalkers on the mission. Mike Barrett, Mission Specialist number 3. He's a veteran of Expeditions 19 and 20 aboard the International Space Station. He spent 197 days aboard the space station and performed 2 spacewalks while he was there. Kennedy Space Center native Nicole Stott, who worked here processing shuttles for many years before becoming an astronaut. She's Mission Specialist 4, hometown of Clearwater, Florida. She flew 87 days on the International Space Station on Expeditions 20 and 21, and also performed a spacewalk of 6 hours and 39 minutes. And the newest member of the STS-133 crew, Steve Bowen, who replaced Tim Kopra after the unfortunate bicycle accident sidelined Tim Kopra. Steve is Mission Specialist 2. He logged 27 days in space with 5 spacewalks. He's a spaceflight veteran. And there we see Peggy Whitson, Jerry Ross, a number of other members of the NASA family helping to prepare today's astronaut crew for their mission to space. And here comes the crew of Space Shuttle Discovery. The STS-133 crew is walking out of their crew quarters in the Operations and Checkout building, followed by some of the astronaut management.
And here we have the crew walking out of crew quarters. This is a very historical walkway. It's the same path that the Apollo astronauts took to go to the moon. And over the last 30 years, there's been 133 odd shuttle crews that have walked out here to catch this bus for the exciting ride out to the launch pad. There you see them standing there just waving to the press and media and the crowd as they board the bus.
This has got to be an exciting moment.
It is, and you sit in the bus and it's an exciting moment, but you know, there is a certain amount of tension in the air, as you can imagine. It's a bit like first night jitters for an actor on a stage show, possibly. You know you're going to go on a great adventure, and it's about to start. This view showing the convoy heading out to the pad, featuring the Astrovan. There you can see some of the employees of the Kennedy Space Center waving to the crew and wishing them well. This is a great moment for the crew to feel the sense of camaraderie and excitement and spirit that the employees offer. You really get a sense that they're with you on this trip, and that they're really behind you and really supportive of you, and a great part of the team.
His storied career began 26 years ago on a beautiful day on the Florida coast.
2, 1. We have SRB ignition and we have liftoff. Liftoff of mission 41D, the first flight of the orbiter Discovery, and the shuttle has cleared the tower.
That was the first of 38 missions for Discovery. It is now the oldest shuttle still in service and has spent 351 days in orbit, almost a year. It's named for two historic sailing ships, one used by explorer Henry Hudson, the other by Captain James Cook. Discovery is now on the launch pad, and it's the 39th mission for that shuttle, and it begins in less than 4 hours. Let's bring up live pictures from Florida's Kennedy Space Center, and they're there on your screens. The 11-day voyage will be Discovery's last in space, unless the U.S. Space Agency changes its mind. NASA is weighing whether to extend the shuttle program into next year. John Zarella is going to tell us more about all of that. So what is the mood like there at the Kennedy Space Center for this last flight? I mean, it's got to be a little bit bittersweet, right?
Yeah, you know, that Hal is exactly the word. I think, you know, everybody around the world needs to just sort of pause and take a look. There's 3 shuttle flights left to go, Discovery, then 2 more down the road into the middle of this year. But, you know, we will probably in our lifetimes never see another vehicle like this, a lifting body that flies up to the International Space Station, has performed, you know, so many tremendous feats in space over the 30 years plus of the space program, you know, and then can return back to Earth and land on a runway. It's just a marvel of engineering. Now, the astronauts are out at the launch pad. They're making their way up the elevator right now. That's why we don't see them on the pictures from NASA television right now. They were down below at the base of the launch tower just a few minutes ago. Again, they're making their way up to the White Room, where they'll get their helmets on and finish putting on the rest of their gear, and then get inside the shuttle for that liftoff, as you mentioned, in just a couple, 3 hours from now. Now, you know, we talk about the fact that NASA they have one more flight in April, and then they are adding a flight in July, the end of June, early July, and that's one that there's been a lot of question as to whether there would be enough money to fly that flight with Atlantis, the shuttle Atlantis. Well, I had an opportunity to sit down yesterday afternoon with the NASA administrator, Charlie Bolden, and he told me in an exclusive interview that there's no question that they need and want that flight.
We have budgeted for 135, and you know, unless something disastrous happens, it's our intent to fly it. It's in the authorization bill signed by the president back in November. So for me, it's the law, and I'm excited about it because I need it. So we plan to fly 135.
You know, they really need it, Hala, because they've got to get some more supplies up to the International Space Station. They want to stock it up. There is nothing bigger out there than the shuttle's cargo bay for carrying stuff up there. They can carry with one shuttle what 5 or 6 of those small expendable cargo ships can carry. You know, one other quick point. There are about 5 or 6 vehicles parked at the International Space Station right now. There have never been so many vehicles up there at one time ever before. It's a real used car lot up there, but a couple of Soyuz rockets, you know, a Progress resupply ship, a Japanese resupply ship, and a European resupply ship that just got there. And then when you get the shuttle up there in a couple of days, it'll be another one. So quite a testament to the international camaraderie that is going on right now in space exploration and space flight.
And this truly is an important final chapter in space exploration in many ways.
Yeah.
And John Zarella is in Florida live.
It is.
Thanks very much. Well, if you'd like to check out our .com page, our web page, we have a great look at the space shuttle era, and there's a video that shows all 132 space shuttles. If you have free time on your hands and like seeing rockets lift off, it's the page for you. You can watch Columbia, Challenger, Discovery, Atlantis, and Endeavour all together. Go to cnn.com/international. That and more, of course, on our webpage. You're at the International Desk. I'm Hala Garani. I'll bring you the headlines next.
Here you can see a camera view from the launch pad itself as the Astrovan is crossing the trackway, the crawler trackway that the crawler uses to deliver the whole shuttle assembly to the launch pad. The crew will step out of the Astrovan, and you'll probably see them step back and look up, which is a little hard to do in the heavy suits that they have. But you get an opportunity to stand there and see the shuttle from a very unique perspective. The view itself is spectacular, but your perspective is particularly unique because you know that it is the ride that's going to take you out into orbit in that amazing 8.5-minute ride that it is capable of executing.
And here we see the flight crew.
Yeah, that's a good view of them walking along the edge of the flame trench to just have a look, do a visual pre-flight of their vehicle in preparation for the ride up the elevator. This is one advantage of launching in the cooler months in Florida, is that this is quite enjoyable to be out there. When you do this in the summer months in those suits, it can get quite hot.
Can imagine that.
There you can see the crew having a group hug and a little quiet moment for themselves to consolidate their thoughts. Wish each other well, and then it's back to work.
And we are at T-minus 2 hours, 20 minutes, 28 seconds and counting as we see Commander Steve Lindsay entering Space Shuttle Discovery. First member to enter traditionally is the commander, and astronaut support person Kay Heyer will assist him into his seat, help configure his communications gear. And not too long from now, we'll be opening up the communications links, and we'll be able to hear Steve Lindsay speak to the Launch Control Center and to Mission Control in Houston. Okay, and handshakes as Mike Barrett prepares to enter Shuttle Discovery on the middeck.
Mike Barrett on board at this time.
And that's OVCC Travis Thompson announcing that Barrett has passed the threshold and is now in the crew module.
1839 GMT. PC copied. OTC, OVCC. Go ahead. TLT Bo on board at this time. Copy that. GMT of 1849.
And I see pilot Bo sliding feet first through the interdeck access onto the flight deck, where he'll be assisted into his PLT seat. Here's a good shot from the window looking left across the flight deck as he comes up to his seat. That's the parachute laying down on top of the seat at the moment.
So the parachute is already in place.
Yes, we put the parachutes on the seat first, and then we put a harness on the crewman, and now he's being assisted up into his seat. He's got to get his feet around the hand controller and stick his feet in the footwell. And I see the chute has moved a little. The chute is on a Teflon sheet that allows it to move around, so they can get the chute right where they want it. Then they pull that Teflon sheet out, and the Velcro sticks, and it stays put.
Nicole giving a sign to her family and preparing to board Space Shuttle Discovery.
OTC, OVCC. Good, OVCC. Nicole Stott on board at this time. All right, that's MS1, and that time GMT is 1910.
And Nicole will be going into seat 3 behind the pilot on the flight deck behind them, and Nicole Stott will be seated in seat 4 during entry, doing the flight engineer duties that Tim Coper had been previously assigned.
MS1 Houston, we read you loud and clear. Good afternoon, Nicole.
And we can see Alvin Drew, who just entered the hatch, making his way into seat number 4.
TMQC, that's complete step 617, an NA for the MS5 slot.
TMQC copied.
Space Shuttle Discovery's journey to today's launch countdown has had a couple of challenges along the way, and here to tell us about the processing is Discovery's Flow Director, Stephanie Stilson.
One of the first things we do after the orbiter returns from a mission is remove the Space Shuttle main engines so that they may begin the refurbishment process. The yellow piece of equipment that you see here is the modified heister that we use to remove the main engines from the orbiter. Removing engines is a very slow and methodical process of ensuring everything is lined up correctly as the engines are removed from the aft compartment. Each engine is 14 feet long and 7.5 feet wide, providing 375,000 pounds of thrust during liftoff. As each engine is removed, it is transported to the engine shop located next to Orbiter Processing Facility number 3. Engineers and technicians then refurbish the engines in preparation for their next use. During the STS-133 processing flow, the right orbiter maneuvering system, or OMS pod, was removed from Discovery to address the failed helium isolation valve issue from the previous mission. The pod was lifted to the transfer aisle prior to being transported to the hypergolic maintenance facility here at Kennedy Space Center for servicing and maintenance. On May 11th, the external tank 137 arrived by barge from the Michoud Assembly Facility in Louisiana. The barge, named Pegasus, is 200 feet long and 35 feet wide and was built specifically for transporting the external tank. Within the confines of the turn basin, a commercial tug carefully assists Pegasus as it maneuvers up to the dock. The external tank inside Pegasus is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. The tank weighs over 58,000 pounds empty. Once on dock, we use the external tank transporter to move the tank off the barge and over to the vehicle assembly building. While the entire offload process takes technicians and engineers approximately 2 hours, the actual travel time is only 10 minutes for the quarter-mile trip. Although the external tank looks like one extremely large tank, it is actually made up of 2 internal tanks. The liquid oxygen tank is at the top or pointed end, and the liquid hydrogen tank is at the bottom. The function of the external tank is to provide liquid hydrogen and liquid oxygen to the 3 Space Shuttle main engines. The aft bipod struts and propellant feed lines you see here connect to the orbiter. The outside of the external tank is covered in a polyurethane foam that protects it from extreme temperature variations seen during flight. Back in the orbiter processing facility, Discovery's midbody is closed out in preparation for rollover. The yellow strong backs you see here assist the payload bay doors to close in the gravity environment of Earth. The Ku-band antenna is used to transmit and receive video and data communications with the ground. The payload bay doors will be reopened again at the pad for payload installation. After spending 119 days in the orbiter processing facility, completing all required maintenance, testing, and checkout, Discovery is now ready to move to the vehicle assembly building, where it will be mated to the external tank and solid rocket boosters. Similar to the tank transporter we saw earlier, the orbiter has a unique transporter as well. The Orbiter Transport System, or OTS, has 76 wheels on 19 axles and was built specifically for the orbiter. Once Discovery is safely in the vehicle assembly building, we begin the process of lifting the orbiter off the transporter and joining it with the external tank and solid rocket boosters. Discovery is secured to the transporter using the same attach points that will eventually connect it to the external tank. There are 2 structural connections in the aft and 1 in the forward. A sling is connected to the orbiter so that cranes can lift Discovery and move it into the vertical position. Lifting the 200,000-pound orbiter requires use of a 350-ton crane and a 250-ton crane. Once Discovery is hanging in the vertical position, the smaller of the 2 cranes is disconnected, and the larger crane lifts the orbiter up and over the transom into the integration cell. It takes approximately 12 hours to lift the orbiter and get it into the mate position. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. Once in place, the orbiter is bolted to the external tank and the sling is removed. Now that the orbiter has been mated, we are ready to move the complete shuttle stack out to the launch pad. The stack is moved by a crawler transporter which weighs 6 million pounds and uses 150 gallons of diesel fuel per mile. A unique viewing opportunity was provided to Kennedy Space Center personnel for the evening of rollout. Employees could bring family and friends out to the turn basin to enjoy the beautiful view as the STS-133 stack slowly made its way to the launch pad. Instead of wheels, the crawler transporter has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. At speed of less than 1 mile per hour, it normally takes approximately 8 hours to travel just over 3 miles from the vehicle assembly building to Launch Pad 39A. Discovery arrived at the launch pad on the morning of September 21st. Once at the launch pad, we spent about a month doing a full system checkout of the tank, boosters, and orbiter in preparation for launch. Here you see the STS-133 primary payload, the Permanent Multipurpose Module, or PMM, carefully being installed into Discovery's payload bay. Following final closeout inspections of the installed payloads, the payload bay doors are closed for flight. The STS-133 crew joined the Kennedy Space Center launch team for the Terminal Countdown Demonstration Test, or TCDT, in mid-October. TCDT is a full dress rehearsal of the final hours of launch countdown and provides key training for both the flight crew and the launch team. The flight crew checks the fit of their spacesuits, practices emergency evacuation procedures at the launch pad, and inspects their mission cargo in the shuttle's payload bay. This training allows them to familiarize themselves with the vehicle and become acclimated with safety equipment and procedures. Astronaut support personnel representatives assist the crew during the TCDT operations. On the morning of November 5th, launch countdown was scrubbed due to a leak at the ground umbilical carrier plate, or GUP, interface on the external tank. The GUP is located at the end of the gaseous hydrogen vent arm on the fixed surface structure of the launch pad. During scrub turnaround operations, a foam crack was also found on the liquid oxygen interface flange of the tank. Both the GUP leak and the foam crack would require substantial investigation and evaluation by the Space Shuttle program over the coming weeks. The GUP plate holds a large diameter pipe that collects excess hydrogen gas from the tank as it is being filled with liquid hydrogen. The venting system funnels the gas to a larger pipe that then takes the hydrogen gas down the fixed surface structure of the launch pad and out to a flare stack that safely burns off the excess hydrogen. At liftoff, the GUP retracts away from the tank, cutting off this connection. The vent arm pulls back to the tower and safely away from the shuttle. Because the GUP's connection to the tank is so important, it has sensors in place to watch for leaking hydrogen. Launch controllers track these readings closely, and if any of these readings are outside the allowable limits, the countdown is halted. After discovering the GUP leak during countdown, the external tank was drained of its liquid hydrogen and liquid oxygen and cleared of excess hydrogen gas. At that point, it was safe for technicians to begin collecting data to better understand and analyze the leak. An investigation team was formed to fully evaluate the hardware configuration, installation, and functionality and determine if any modifications would be necessary. Teams performed an initial inspection of the flight seal and quick disconnect prior to sending them to the lab for extensive micro-level inspections. As part of the investigative effort, the complete ground umbilical carrier assembly and vent line was disassembled and inspected. The same repair is performed on the other crack stringers found at the launch pad. In addition, a radius block modification was also performed on the intertank stringers. The radius block modification provides additional structural support in areas known to carry much of the structural load of the external tank. These radius block essentially fit over existing stringer edges through which securing rivets are installed to provide additional structural support. Once all repairs were made to the external tank, the stack was again placed atop the crawler transporter and carefully rolled out to Launch Pad 39A on January 31st. Brilliant xenon lights illuminated the vehicle, creating a spectacular view for everyone present. To verify the integrity of these repairs, an instrumented tanking test was performed on December 17th. Numerous strain gauges and temperature sensors were installed to record data from the tank as it chills and warms again during the loading and offloading of propellants. Following the completion of the instrumented tanking test, we rolled the shuttle stack back to the vehicle assembly building for further non-destructive evaluation, or X-rays, of the external tank stringers that were not accessible at the launch pad. Rollback occurred on December 22nd, and engineers immediately began inspecting and evaluating the external tank. X-rays revealed an additional 4 small cracks on 3 stringers. These stringers would require the same repair as performed on the other crack stringers found at the launch pad. In addition, a radius block modification was also performed on the intertank stringers. The radius block modification provides additional structural support in areas known to carry much of the structural load of the external tank. These radius block essentially fit over existing stringer edges through which securing rivets are installed to provide additional structural support. Once all repairs were made to the external tank, the stack was again placed atop the crawler transporter and carefully rolled out to Launch Pad 39A on January 31st. Brilliant xenon lights illuminated the vehicle, creating a spectacular view for everyone present. Once back at the launch pad, a full system checkout of the tank, boosters, and orbiter was completed in preparation for launch. STS-133 is the 133rd Space Shuttle mission and Discovery's 39th and final mission.
Thank you very much, Stephanie. It's nice to have you here in the firing room next to us today.
It's great to be here. Launch day is always a good day.
It is a good day. But this has to be a little bit of a bittersweet moment this time around, since we're talking about Discovery's last flight, and you've been with the Discovery team for a long time as the flow director. How does it feel today?
Well, you're right. It has been bittersweet. Whenever we achieve major milestones along the way, say rolling out of the OPF, rolling out to launch pad, there tends to be some tears there, tears of joy, excitement to be past that major milestone. This time around, there was a little bit of an underlying sadness as well, because it's the last time we're going to be processing Discovery for flight. So the team, although excited about being here on launch day, there is some emotion, and I expect that when we lift off today, we'll see quite a bit of emotion here in the firing room and with the rest of the processing team who are outside with their friends and family ready to watch liftoff.
And it will be another emotional moment when Discovery lands back here at Kennedy Space Center in about 11 to 12 days. When that happens, what will happen with Discovery?
Well, what we'll do initially is basically business as usual. We go into what we call our down mission processing. And basically that's about a month worth of work where we're first safing the vehicle, getting it back into the orbiter processing facility, draining hazardous commodities so that we can get access to the vehicle and put personnel in there. At that point, the main thing we're looking for is there anything with Discovery that we saw on orbit or in inspections that we do on the ground that would require us to go do anything different on the other 2 vehicles that still have a flight to go. So we'll do that, do those inspections and so forth. At that point, then we get into what's the new part of our job, and that'll be the transition and retirement of Discovery. And the first stage for that is called the in-state safing. And basically at that point, the vehicle has been safe enough for technicians and engineers to work on it, but now we need to make it safe enough for the general public to be around and close up with the vehicle itself. So there's different commodities that we'll have to offload to ensure hydraulics, ammonia, cryogenics, those hypergols, those kind of things, as well as pyrotechnics and so forth. So we'll take care of that. At that point, we'll also look to pull out the main engines. Those will be removed and reused. We'll also have pulled out payload components that are necessary. And then there are going to be some avionics boxes and components of the vehicle that will be pulled out and used for future type of research or future projects and things like that. So we'll do that. The next stage then at that point is to prepare Discovery to be ferried to the display site. So we'll have to put the OMS pods and the forward reaction control system back on, put engine simulators in and so forth, and get it ready to go out to the mate-demate device out by the runway, load it up on the shuttle carrier aircraft, and then ferry it off to its final destination. When we get there, we have the task of then offloading from the SCA, taking Discovery into its display area and doing the final touches to get it into a preparation for being displayed by the general public.
And your team will be involved in all that process?
Absolutely. All the folks that have worked on all the vehicles throughout the history of the shuttle program, same people, engineers, technicians, quality, safety, planners, schedulers, they'll all be involved with this transition retirement activity as well.
That's great. Well, since your team has been working so hard on this shuttle for so many years, some folks came up with an idea. There's a traditional liftoff line that the Public Affairs Office commentators utter at the time of liftoff, and your team was asked to come up with a liftoff line this time to be used at the time of liftoff. Can you tell us a little bit about that process? And,
sure.
And without revealing the line, maybe...
Yes, I won't steal your thunder and read the line by any means. No, what a great honor to allow the team to come up with that final liftoff line. And so basically what I did was I sent an email out to the leads of the Discovery's team to basically describe what we were looking for and give examples of previous liftoff lines, the criteria and so forth that go with that. And then all the leads then dispersed it out through email to all their distribution lists. That's the quickest way we can get the word out, is via email. At that point, then individuals were able to submit those ideas to me, and I consolidated them and passed them on. And then the selection committee actually was able to pick the one they thought was best, and I think they did a real good job with that. And are we allowed to say whose selection was?
Yes,
okay.
Please do.
Mary Butler of the United Space Alliance was the one who submitted the winning liftoff line. And Mary has been with United Space Alliance working shuttle since '96. She's in the guidance and navigation group, so basically she does all the systems checkout and testing of the navigation systems and radar and so forth. And she's actually a member of the Prime launch team, so she's in here today getting ready for liftoff. And her husband John as well is also on the Prime launch team. So really excited for Mary to have submitted that, and we're really excited to have everybody hear it.
Yep. Well, we're going to be excited to speak it. So that's wonderful, and we really appreciate Mary's line and the effort that your whole team put in on coming up with those liftoff lines. There were a lot of good ones, and it was a hard choice for the selection committee.
I can imagine. We're all very excited and very proud to be part of Discovery's team. So thank you for talking to me today.
You bet. Thanks again for being with us, Stephanie.
You're welcome.
And we are pleased to be joined here in the firing room by Scott Higginbotham, who is the payload manager for STS-133. And Scott, it's nice to have you here today.
It's certainly great to be here today.
You have been following this flight for some time with the delays that we've had, and you've had a number of payloads ready to go. And can you just kind of briefly tell us a little bit about that?
Yeah, absolutely. We closed the payload bay doors back on the 16th of October of last year, and at that point our two primary payloads for this mission, the Permanent Multi-Purpose Module and the Express Logistics Carrier 4, were closed out and ready to fly. And they've remained that way ever since, and they continue to be ready to go today, and if we need to delay for whatever reason, we'll continue to wait. So the beauty there is they're fairly insensitive to the passage of time, so we left the doors closed and followed the orbiter and went with it when it went back to the VAB and then back to the pad again. Up on the forward end, in the crew module, we did have a number of experiments that we removed after the last attempt. We turned them back over to the experiment developers. They refurbished them, and we reinstalled them both on Monday and yesterday, and finally all of those are on board and ready to go fly.
So no significant changes caused by the delays, and you're ready to go. And we have a tape, I know, that we can roll that will allow you to explain a little bit more about what we're doing. So we'll roll that tape.
Yeah, we're going to compress about 18 months of work into about 5.5 minutes. All right, this is a C-5A military aircraft. It delivered Express Logistics Carrier 4 to us from the Goddard Space Flight Center back in mid-August of '09. The Goddard team, under the direction of Kevin Carmack, put the ELC carrier together, and then we here at KSC with our Boeing colleagues finished the outfitting of that element. The permanent multipurpose module Leonardo returned on the 19A STS-131 mission back in April of last year, and it returned to our building on the 26th of April, where we pulled all of the cargo out from that last flight and started the modification process to get it ready to become the PMM. That work was performed predominantly by our Italian colleagues from Thales Alenia Space under the direction of Roberto Barreto. They did a wonderful job, and by the end of July they had the element converted to a PMM. During our processing flow, we perform a number of tasks to get the module ready to go fly. This will be the 8th flight of Leonardo, and in this scene you can see a simulator of the docking mechanism on the station that we made up to the docking mechanism on the module every flight to ensure that it's going to seal properly against the station, this time for final assembly and installation onto the station. Here's ELC-4 being moved over to our element rotation stand. We did that periodically throughout the floor, as there's a top surface and a bottom surface on that element, and we need to be able to flip it over like a pancake. And once the internal modifications were completed in early July, the external mods continued on for a while. We started our rack installation process. We have 14 racks flying up with us in the module and carrying up a total of 8,500 pounds of cargo. The external mods continued in parallel with that, and this is a view of some of the Thales Alenia Space personnel installing some of the modified blankets and shielding on the exterior of the vehicle. These new shields were installed to help the vehicle survive the 10 years it's going to see in space. The very large ORU flying on ELC-4, the one and only, is a thermal radiator for the exterior of the station. We hope we never have to use it, but we'll have it pre-deployed there if necessary, and that's a shot in August of us installing that. Once ELC-4 was completed, we lifted it up and mated it to its keel assembly. It uses this keel assembly when it's installed in the orbiter to survive ascent loads. The keel does stay behind when the element is deployed to the station and will be one of the few things that will return home in Discovery's payload bay. After that, the element was weighed and installed into our transportation canister. Robonaut 2. R2 arrived at KSC in early August and went through about a week of post-delivery checkout and preparation activities. In the end, after they checked out all of the operations of the robot, we packaged it up into its launch enclosure and installed that launch enclosure into the module for flight. In early October, on the 5th, the element was lifted out of its work stand for the last time. We weighed it, calculated its center of gravity, and then moved it over into our transportation canister. In this view, you can see it being lowered down onto the load cells that are used to actually measure the weight of the element. The ELC-4 element had been installed in the canister just prior to this, so the PMM was the second and last element to go into the canister. The plastic you see there draped over the docking mechanism is intended to protect us from some minor contamination that we might see during our transport out to the pad. It's removed during our final closeout operations out at Pad A. Once both elements are in the canister and the doors are closed, it's moved over to our canister rotation facility where it's tilted up on end atop the transportation mobile transporter that we use. And on the 7th of October, my wedding anniversary, we delivered both elements in the canister out to the pad. We usually do this in the middle of the night to avoid traffic and because the weather is generally better for us. It takes about 4 hours to get there, very slowly and very carefully. Once up on the pad surface, we hoist the canister up into the rotating service structure, which you can see has been pulled back away from the orbiter. Inside the rotating service structure, there's a large gantry called the payload ground handling mechanism that can actually reach in and extract the payload elements from the canister. The canister can then be lowered and taken away. The RSS is rotated around the orbiter, and the elements are installed by that ground handling mechanism into the orbiter. Once we made all the appropriate electrical connections and did our final closeouts, hey look, that's me. We performed our final closeouts out at the pad, and on the 16th of October, we closed the payload bay doors for flight. Again, that was quite some time ago, but I'll never forget that day. A lot of us like to go out and watch that because that's our last opportunity to basically blow our hardware a kiss goodbye. And that's where we've set ever since. Again, we've gone a few miles horizontally, and hopefully today we'll go a few miles vertically and get these two elements in space and attached to the International Space Station where they belong.
It's quite a lot of work, quite a lot of detailed work to get the payloads ready to go fly into space.
Absolutely. It's a team effort with great folks all around the United States and all around the world for that matter. We spent a lot of time on this mission in particular working with our colleagues from Italy, and that's been an absolutely wonderful experience.
Absolutely. Well, we also have another tape that we wanted to play in which you sort of give us a tour of the permanent multi-purpose module. We look forward to taking a look inside.
All right, great.
The permanent multi-purpose module, once again, is a modified version of the Leonardo multi-purpose logistics module that flew in space 7 times, I believe, and carrying hardware to and from space. And in this case, it's been modified to become a permanent module that will not come back to Earth.
Right. This module is going to serve as that extra closet or extra garage bay that you always wish you had. You know, the station's growing and the cargo on board is taking up a lot of space, so we just need some more places to stash things, and the PMM will provide us some very much needed space. So this is a view looking in the hatchway, and I think next we're going to proceed on inside. This was taken during our final phases of our closeout activities, so all the cargo at this point is on board. The great big white box you see in the back in that original image was Robonaut 2 packaged up in his enclosure, and you can see him there on the far right hand side of the screen right there. A lot of cargo items are they're large and oversized, so they're in special containers that we strap into place, and you can see that they're covered in foam for protection. We have an extra treadmill that we're carrying up, some spare parts for the thermal control system for the station, food, all manners of things that the crew needs to live and work in space. Again, 8,500 pounds of cargo. Some of that cargo is going to be used right away. Some of it's going to be used later on over the station's lifetime. And certainly much of this volume inside this module will be filled up with additional cargo items once the element gets on orbit and attached to the station. There are a few empty rack bays. We don't have enough performance to carry up a full module on this flight, so those empty rack bays will again be filled with cargo later on. And here's Robonaut 2 again running through his paces. He's an absolutely amazing device. He will teach us a lot about how robots can help us in space, both inside the station and ultimately outside the station. And perhaps one day we'll be able to use robots that can trace their lineage back to Robonaut to do some of the more dangerous and maybe mundane things in orbit so that the crew can be freed up and protected from those things. Leonardo is basically a very low mileage used spacecraft, the way we look at it. He's flown for about 90 days in space and cumulative time, and has traveled, I think, 40 million miles in total so far. But over the 10 years that we expect the module to stay in space attached to the space station, we have calculated that roughly it will travel about 10 billion miles, and so it's got a lot of good miles left in it. We're sad to see Leonardo go. He's been part of our family for over a decade, but we're all excited to see him put to good use as a permanent addition to the space station as opposed to ending up in a museum somewhere.
Absolutely.
So it's a real thrill for my team to be here today. It's been a long journey. It's been an exercise in patience, but we're expecting the payoff today, and actually a few days downstream. For us, really the big day is the day that the element's deployed and attached to the station and onto its new permanent home.
That's just days away. I think today looks like a good day, so we'll keep our fingers crossed.
Yes, indeed. Looks like a good day to go fly.
All right. Thank you very much, Scott.
You're welcome.
Among other headlines, in less than 2 hours, the U.S. Space Shuttle Discovery will begin its 39th and final mission. The 6-member crew is strapped in and ready for an 11-day round trip to the International Space Station. These are live images you're seeing coming to us from Florida. The final flight for the Shuttle Endeavour is set for April, and that leaves only the Atlantis. Its final mission is tentatively set for this summer.
Und es sieht so aus, als könnte es diesmal klappen. Die Wettervorhersage für den Weltraumbahnhof Cape Canaveral ist gut und es gibt laut NASA keine bedeutenden technischen Probleme. Auf ihrem Abschiedsflug soll die Discovery einen Roboter zur Raumstation ISS bringen. Danach geht das Shuttle nach rund einem Vierteljahrhundert Einsatz in Pension.
Ihre bemannten Space-Shuttle-Flüge in den Weltraum haben die Amerikaner ja praktisch auf Eis gelegt. 3 letzte Flüge gibt's noch, dann war's das. Aus Kostengründen und weil bei den Flügen immer wieder so viel schief ging. Aber dort oben fliegt ja immer noch die ISS herum, die internationale Raumstation, in der Astronauten arbeiten und forschen. Die wollen versorgt sein. Das übernehmen künftig Russen, Europäer und Japaner. Heute dockte ein europäisches Versorgungsschiff an die Raumstation an. Es brachte Lebensmittel, Post und nicht zuletzt frische Socken ins All. Mehr dazu von Hildegard Werth.
Vor einer Woche war das automatische Transportraumschiff Johannes Kepler auf einer Ariane-Rakete gestartet. Nun tastet es sich Zentimeter für Zentimeter an die Raumstation heran. Ein heikles Manöver bei 28.000 Stundenkilometern. 1 Minute vor 5 heute Nachmittag macht es Klick. Das perfekte Rendezvous gleich im ersten Anlauf hoch über der Westküste Afrikas. Die europäischen Frachtraumschiffe werden in Bremen gebaut. Und sie sind lebenswichtig für die Versorgung der ISS. Denn noch in diesem Jahr werden die Space Shuttles stillgelegt. Dann übernimmt Europa einen großen Teil der Verantwortung für den Nachschub der Station. Johannes Kepler bringt, wie schon sein Vorgänger Jules Verne vor 3 Jahren, 7 Tonnen Versorgungsgüter von frischen Socken bis zu wissenschaftlichen Messgeräten. Für 96 Tage hat die Besatzung der ISS nun ein zusätzliches Zimmer, ein beliebter Schlafplatz für die Crew, denn im ATV ist es leise, himmlisch ruhig sogar im Vergleich zum Rest der Station. Am Wochenende soll die ISS noch mehr Besuch bekommen. In Cape Canaveral wurde die Raumfähre Discovery zum letzten Mal zum Startplatz gerollt. Es ist ihr allerletzter Flug nach fast 30 Dienstjahren. Der Abschiedsschmerz ist groß bei den Mitarbeitern der NASA und bei Zehntausenden von Schaulustigen, die heute Nacht zum Start erwartet werden.
NTD, this is SRO on 212. That SRO? Range status is no-go at this time. Central Command remoting system is partially operational. When selecting a screen, the string will go down. And they experienced this event last night. I had confidence in the system as long as they didn't select that screen, that we were confident in the system. However, the same event was experienced when selecting a different screen. They are not confident in the system at this time, and range status is no-go.
Discovery Launch Director, head of Ground 1.
Go for Discovery.
Okay, Steve, I don't know how much you've been following this, but the range is having a little bit of an issue with their range safety command system, the display of their command system, and they're talking it actively over there. Hopeful that we'll get through it. Not quite sure if we will yet or not, but the right people are working on it. So we're going to take this one on down to the wire. We'll go through our polls here and take you on down to 5 minutes and see if we can't get you a good flight today.
Sounds like a great plan, Mike.
This is Shuttle Launch Control. 5 minutes remaining in our hold at T-minus 9 minutes.
This is the NTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC, OTC go. TBC, TBC go. PTC, PTC's go. LPS, LPS is go. Houston flight.
Houston flight is go.
Mila. Mila's go. STM. STM is go. Safety console.
Safety consoles go.
SPE. SPE is go. LRD. LRD is go. SRO. SRO is go. Copy. Are you go to 5 minutes and hold? Yes, we are good to go 5 minutes and hold. Copy. And CDR. Discovery is go.
Launch Director NTD.
Yes, sir.
Our launch team is ready to proceed. SRO has concurrence to go to 5 minutes.
Okay, copy all that. I'll do my polls this time. KC Chief Processing Engineer, verify no constraints to launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
KSC Safety Mission Assurance is go pending resolution of the range issue.
Copy. Payload Launch Manager.
Mike, the Space Station Processing teams go.
Copy. Range Weather.
Weather has no constraints for launch.
Copy, thank you, Kathy. And Ops Manager.
Copy, Mike. On our side, MMT's in really good shape. The vehicle's looking perfect. Weather's looking great. We'll stand by here and see if the range can resolve their issue, but we are go.
Okay, copy that, and we'll take it on down to 5 and see if we can't get there.
Yeah, it's a good plan, Mike. Let's keep going.
And KC Safety and Mission Assurance.
KSC Safety and Mission Assurance.
Let's see, if we get the go from SRO, you're going to be go. Is that affirmed? We don't have to re-poll you.
Mike. Yes, we are go.
Right, so we will not re-poll you if we get a go from SRO.
That's affirmative.
Thank you, sir.
Concur.
Is SRO?
We're looking at Shuttle Launch Director Mike Leinbach, Assistant Launch Director Charlie Blackwell-Thompson to his side, and Stephanie Stilson, Discovery Flow Director.
CGLS, NTD. CGLS. Okay, we're going to pick up the count here shortly. Once we start counting, I need you to insert a hold at 5. GLS copies will insert a hold at 5 minutes.
NASA Test Director Steve Payne reminding the ground launch sequencer team to insert a hold at T-minus 5 minutes. We will be coming out of our hold at 9 minutes and counting down to 5 to enable the range safety officer and the range team a few more minutes to work their problem. They currently are no-go.
Clock will start in 2 minutes.
2 minutes remaining in our hold at T-minus 9 minutes. Again, our only issue is a red condition from the Eastern Range. Their central command system display is not operating properly, and it needs to be for them to give a go for launch. 1 minute, 30 seconds remaining in our hold.
NTD ISL. Go ahead. Recorder activation complete. Copy.
55 seconds remaining in the hold. Once again, we will come out of the hold at T-minus 9 minutes. We will count down to T-minus 5 minutes. Between now and then, if the range safety system condition is corrected, we will continue to count down for launch. If not, we will hold at 5 minutes. "25 seconds remaining in our T-minus 9 minute hold. Just a few seconds away from resuming our countdown.
Countdown clock will resume on my mark.
NTD safety.
3, standby safety. 2, 1, mark. T-minus 9 minutes and counting. GLS auto sequence has been initiated.
And the ground launch sequencer has been initiated. All countdown functions now automatically controlled by the GLS computer located in the firing room integration console.
Thank you.
Our window will expire about 5 minutes after our preferred launch time. T-minus 8 minutes, 17 seconds and counting. All systems are go, except for
buses to fuel cells per your checklist.
PLT in work.
except for the range safety officer. We stand by as they continue to work through their problem.
OTC, PLT, essential buses connected to fuel cell.
Pilot Eric Bowe flipped switches in the cockpit to connect the 3 fuel cells directly to the essential power buses.
Thank you.
T-minus 7 minutes, 30 seconds and counting.
GLS is go for orbiter access arm retract. And Discovery OTC from the processing team of Discovery to the crew of Discovery. Enjoy the ride.
Thank you very much. Thanks for all the work you did getting this ready to go, and appreciate all your work. And for those watching, get ready to witness the majesty and the power of Discovery as she lifts off one final time.
Orbiter access arm retracting. Orbiter test conductor John Craxton talking with Space Shuttle Commander Steve Lindsay.
And NTD CGLS, we've inserted a hold, and the clock will hold at T-minus 5 minutes. Copy, thank you.
T-minus 6 minutes, 50 seconds. Planning to hold at T-minus 5 minutes unless the range is clear.
Zero.
Can you give us an update on your repair?
There's no changes to that, sir.
Copy, no change. JRPS OTC start ATU display recorders. Can work. PLT OTC perform APU pre-start.
PLT is in work.
RTC JRPS display recorders are running.
T-minus 6 minutes, 4 seconds and counting. Orbiter test conductor John Craxton gave pilot Eric Bowe the go to perform the auxiliary power unit pre-start procedure. The APUs provide pressure to the shuttle's 3 hydraulic systems that move the main engine nozzles and aero surfaces. T-minus 5 minutes, 40 seconds and counting. T-minus 5 minutes, 30 seconds and counting. T-minus 5 minutes, 4 seconds and counting.
Countdown clock is holding at T-minus 5 minutes due to manual request.
Countdown clock is holding here.
5-year well, we'll troubleshoot our Eastern Range Central Command reporting system issue.
2 minutes and 48 seconds of hold time remain in today's launch window of Space Shuttle Discovery. Today's launch window expires in 2 minutes, 28 seconds.
And NTD CGLS, we did get an indication that the range safety did throw their hold switch. That's affirmative.
All systems are go with the exception of the Eastern Range. And they continue to troubleshoot a problem with their Central Command system display. Two minutes remaining in the hold today. 2 minutes remaining in our launch window.
SRO NTD final recommendation, please.
Standby 1.
NASA Test Director Steve Payne checking with the Eastern Range on their status to pick up the count. We have 1 minute 30 seconds remaining in our window today.
minus 2.5 minutes. It's a watershed moment for the US space program as one of its most famous shuttles prepares for a final send-off. Will it go? Stay with us.
40 seconds remaining in our launch window.
Hoffentlich im Laufband gesehen, übertragen wir jetzt live den letzten Start der US-Raumfähre Discovery. Zur Wirtschaft kommen wir denn, wenn alles glatt läuft, etwas später. Hier sehen Sie die ersten Live-Bilder aus Cape Canaveral im US-Bundesstaat Florida.
Ja, in wenigen Minuten soll es soweit sein. In Cape Canaveral, dem Weltraumbahnhof, soll um 16:50 Uhr, also 22:50 Uhr unserer Zeit, das wäre in knapp 2 Minuten, die Discovery zu ihrem Abschiedsflug abheben. Es ist ihre 39. und letzte Reise und die erfolgt mit 4-monatiger Verspätung, Pannen, Pech und Terminproblemen. Es verzögert sich, hat sich also damit der letzte Start immer wieder verzögert.
Ja, und zu den Problemen, liebe Zuschauer, gehörten Risse am Außentank. Das war eigentlich das Hauptproblem und es gab natürlich auch noch andere Defekte. Ja, und jetzt hebt die Discovery zu ihrer letzten Mission ab. An Bord sind übrigens 6 Astronauten, darunter auch eine Frau. Ihr Ziel ist die internationale Raumstation ISS, wie immer. 11 Tage soll diese letzte Reise dauern und Hauptaufgabe der Shuttle-Mission immerhin Nummer 133. Unter der Leitung von Kommandant Steve Lindsay ist es, unter anderem einen Roboter sowie Anbaumodule zur ISS zu bringen.
Und ich darf am Telefon begrüßen Friedhelm Klaassen, er ist Raumfahrtexperte der Deutschen Luft- und Raumfahrtgesellschaft. Guten Abend, Herr Klaassen.
Flight for the fabled ship, the 6-member crew planning to deliver a storage module, a science rig and spare parts to the International Space Station during its 11-day mission. I'm joined live by Rice Space Institute Director Patricia Rife, who can tell us more about the mission. When I say it's planning to deliver these things, it makes it sound all so normal, but it's not, is it? I mean, this is quite something. How does it feel to be witnessing the end of an era?
Well, it is kind of scary because it's been almost 30 years now since the very first space shuttle mission, and it's kind of a bittersweet time to see Discovery going to be retired after this shot.
We've just heard them say sort of minus 4 minutes or so. It's supposed to go off at 50 minutes past the hour, so they appear to have some technical issues. At this point, do you expect it to go?
We don't know. There was an Eastern Range problem, so they're making sure there's nobody's in the way and making sure that all the range, downrange indicators are good.
Okay, we're looking at the clock there. 2 minutes, 51 seconds to go. When you say they're making sure nothing's in the way, what do you mean by that?
Well, there's several things that can be a problem with range. One is there might be a sailboat that's downrange in a place where it might have to board to. So they have to make sure there's no aircraft, there's no sailboats in the path of the launch.
We're saying this is the 39th flight for what is a fabled ship. It's going to the International Space Station. What is going on there at the moment?
Well, of course, there's always a permanent crew at the space station, but what's really exciting about this mission, it's going to bring its first robot to space. The Robonaut 2 is going to be coming as part of the Leonardo Permanent Multipurpose Module, and that is going to be very exciting to have now a robot in space for the first time to join the human crew.
All right, we're within 2 minutes. If it goes off, what will the astronauts on board be thinking at this point?
Well, of course, the G-forces are going to be pretty tough here for the first few minutes. It will shake and rock and roll quite a bit. Then it will hit a point of maximum G-force. It will release its solid rocket boosters, and from then on, it should be smooth sailing.
I was talking to John Zarella just earlier on. You can see the people there on the coast. minus 1.5 minutes and counting at this point. There are thousands and thousands of people still interested in these sort of missions. What's the appeal, do you think?
Well, of course, seeing the Earth from space is just absolutely spectacular. It was predicted that the first time we went into space, we would look back on Earth and realize what a fragile, small place it is. And there's no greater rush than seeing our home planet from outer space.
Right. Let's listen in, because I think we're close.
Running on its 3 onboard fuel cells. Coming up on a go for auto sequence start at T-minus 31 seconds.
CLS is go for auto sequence start.
And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. 20 seconds. The sound suppression water system
15.
has been activated, protecting Discovery and the launch pad from acoustical energy waves.
CLS is go for main engine.
Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's Space Shuttle team. The shuttle has cleared the tower.
This is Mission Control Houston. The Space Shuttle now rolling over onto its back for the 8.5-minute ride into orbit. Discovery now making one last reach for the stars. Throttling down as the orbiter passes through the area of maximum pressure, reducing the stress on the shuttle as it goes supersonic.
And these are remarkable pictures as we watch what is the final flight for the fabled ship Space Shuttle Discovery, taking off on its last mission. The 6-member crew planning to deliver a storage module, a science rig and spare parts to the International Space Station during its 11-day mission. And I've got an expert with us, Patricia Wright. How long is it going to take them to get there?
Getting to orbit's not that takes pretty quick, but then they have to get into the exact alignment with the space station orbit. That's why the time of launch is so critical, so they can get in the same plane with the space station, and then they have to catch up with it and do maneuvers. So it'll be a while before they actually connect to the space station.
I want our viewers to get another minute or so as they watch. I mean, these are always remarkable to see, aren't they? And the pictures just get better and better as the years continue. So how will those astronauts be feeling now?
They're still getting pretty heavy G-forces. You notice that we're losing the solid rocket boosters. That's a very good sign. Those are basically like Roman candles. When you light them, they're on till you let them go. So now they're under control of their main engines, which is a lot safer.
1,189 miles an hour.
Remarkable stuff.
7 miles, downrange from the Kennedy Space Center, 53 miles. Discovery now getting a
now you can really see the curvature of the Earth from space, even only up 3 miles as they are now.
2 minutes and 32 seconds.
Your 2-engine TAL, we do have updates.
Patricia, it's been an absolute pleasure as we watch Discovery make its final frontiers voyage, as it were. We're going to leave those pictures here on CNN International. A successful last takeoff for Space Shuttle Discovery. Patricia, we thank you very much
so you're
indeed.
pressed to ATO 11.
Before we take a short break and we get
an diesen Shuttles?
Man hat natürlich die Probleme mit dem externen Tank, die wir jetzt hier bei dieser Mission im Vorfeld hatten, sehr ernst genommen und die externen Tanks für die nächsten beiden Shuttle entsprechend überprüft und modifiziert, sodass man diese Probleme dort nicht mehr erwarten braucht. Ansonsten gibt es keine grundsätzlichen Probleme für die Missionen. Die werden also noch planmäßig durchgeführt werden. Es gibt für die allerletzte Mission im Juni noch etwas Finanzierungsprobleme, aber ich denke, auch die wird die NASA in den Griff bekommen, sodass wir davon ausgehen können, nach dieser Mission jetzt noch 2 weitere Missionen und dann ist das Shuttle-Programm endgültig zu Ende.
Nun ist sie ja nicht allein da oben, die Discovery, wenn sie hochfliegt. Die Johannes Kepler ist schon oben, die ist heute nämlich gelandet. Das ist ein europäischer Raumtransporter. Was können Sie überhaupt zur Zukunft der ISS sagen?
Ja, die ISS wird mindestens noch bis 2020 betrieben. Das sind die Beschlüsse der internationalen Partnerschaft. Technisch gesehen gibt es schon Aussagen, dass die ISS wahrscheinlich sogar bis 2028 betrieben werden kann. Also wir haben jetzt die eigentliche Nutzungsphase noch 10 oder mehr Jahre vor uns. Die ISS ist ja gerade erst komplettiert. Wir haben jetzt in Europa praktisch den regelmäßigen Versorgungsflugbetrieb zur ISS. Heute mit dem Andocken des ATV, gegen 17 Uhr war das, Johannes Kepler. Es kommen weitere ATVs bis 2014 oder 2015. Danach muss man sehen, ob man die Fahrzeuge, die man heute hat, oder auch Weiterentwicklungen dieser Fahrzeuge dann zum Einsatz bringt. Es gibt natürlich auch die Möglichkeit, das ATV zu modifizieren, sodass man Teile des ATVs wieder auf der Erde landen kann, dass wir auch praktisch Rücktransport von Materialien von der ISS zur Erde damit ermöglichen können. Das Szenario ist sehr weit offen. Man kann noch sehr viel aus der ISS machen und sehr viel auf der ISS forschen und Ergebnisse jetzt erst gewinnen.
Friedhelm Klaassen, vielen herzlichen Dank, dass Sie uns für den Moment zur Verfügung gestanden haben. Sie bleiben aber weiter in der Leitung.
Ja, liebe Zuschauer, das war der Abschiedsflug der US-Raumfähre Discovery.
Ja, und das ist das Ende unserer Live-Berichterstattung aus Cape Canaveral in Florida. Und wir haben es gesehen, alles wunderbar gelaufen. Das Wetter hat auch mitgespielt und mit großer Verzögerung ist sie gestartet.
Ops Manager on 212.
Go ahead.
I got verbal confirmation from the 45th Wing Commander. We are go, and we do not need SRO's go, so I would like you to proceed.
Copy that. NTD with that verification that range will support today's launch. You need to press on. Pick up the clock on your mark.
Copy that. And SRO NTD, need to put this your hold switch to proceed position.
40 seconds remaining in our launch window. Range is go.
TLS, has the SRO hold been removed?
Negative, sir.
SRO NTD. NTD, I can remove the hold here.
SRO on 212.
So need to put your hold switch in proceed position.
Hold fire on proceed.
TLS, can you verify? TLS verifies.
15 seconds remaining in our hold.
Copy. Inspection on that will pick up momentarily. CGLS, pick up the clock on your mark. TLS copies. 3, 2, 1, mark. T-minus 5 minutes.
T-minus 5 minutes and counting.
TLT, OTC, perform APU start.
TLT in work.
And CDR, OTC, reconfigure heaters.
Copy in work.
T-minus 4 minutes, 41 seconds and counting. All systems are go and weather is green.
Flight director entity. Flight entity.
NTD Houston flight. I have 2 seconds of drain back hold remaining. 2 seconds.
OTC, PLT, 3 good APUs.
Copy that.
Pilot Eric Bowe reporting 3 good auxiliary power units.
SRO.
T-minus 4 minutes and counting.
US is go for put 4.
The final helium purge of the 3 main engines is underway in preparation for main engine start.
Go for 10 minutes comes MT0, range status is go for launch, and what is your status?
We are go.
Copy.
Final test of the flight control surfaces is underway. This is a pre-programmed pattern of movements designed to verify the readiness of the flight control surfaces, the elevons, speed brakes, and rudder. Minus 3 minutes and 30 seconds and counting. Final aero surface checks are complete. Discovery's 3 main engines will be gimbaled through a pre-programmed series of maneuvers as a final test before launch. T-minus 3 minutes and counting. Final pressurization of the external tank's liquid oxygen tank is underway.
Go for ET LO2 pressurization.
And we're completing purge of the shuttle main engines.
TLT OTC, clear caution and warning memory. Verify no unexpected errors. TLT in work. OTC, TLT, no unexpected errors.
The gaseous oxygen vent hood, or beanie cap, is slowly being retracted away from the top of the external tank.
Close and lock your visors and initiate O2 flow. Copy on work.
Orbiter test conductor John Craxton requesting pilot Eric Bowe clear the caution and warning memory system. T-minus 2 minutes and counting.
GLS is go for ET LH2 pressurization.
Liquid hydrogen replenish on the external tank is being terminated as planned. T-minus 1 minute, 30 seconds and counting. All systems are go. About 90 seconds away from the launch of Space Shuttle Discovery on her final mission. T-minus 1 minute, 10 seconds and counting. The liquid hydrogen tank inside the external tank is now at the proper flight pressure. T-minus 1 minute and counting. The ground launch sequencer will verify that the 3 main engines are ready to start. The booster joint heaters are being deactivated at this time. T-minus 48 seconds and we're transferring to orbiter internal power. Discovery is now running on its 3 onboard fuel cells. Coming up on a go for auto sequence start at T-minus 31 seconds.
GLS is go for auto sequence start.
And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. 20 seconds. The sound suppression water system
15.
has been activated, protecting Discovery and the launch pad from acoustical energy waves.
GLS is go for main engine.
Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's space shuttle team. The shuttle has cleared the tower.
This is Mission Control in Houston. The space shuttle now rolling over onto its back for an 8.5-minute ride into orbit. Discovery now making one last reach for the stars. Throttling down as the orbiter passes through the area of maximum pressure, reducing the stress on the shuttle as it goes supersonic.
Discovery Houston, you are go at throttle up.
Commander Steve Lindsay acknowledging the call from Capcom Charlie Hoba as Discovery's 3 main engines throttle back up. Lindsay is joined on the flight deck by pilot Eric Bowe and mission specialist Al Drew and Nicole Stott. Mission specialist Mike Barrett and Steve Bowen. Discovery's 3 main engines are burning fuel at a rate that would drain an average swimming pool in about 25 seconds. The engines combined with the solid rocket boosters produce more than 7 million pounds of thrust. 1 minute, 50 seconds into the flight, we're standing by for separation of the twin solid rocket boosters. Discovery now traveling 2,695 miles an hour. Its altitude 24 miles. Downrange from the Kennedy Space Center, 29 miles. Booster separation confirmed. Discovery's guidance is now converging as the shuttle's onboard computers fine-tune the flight. Two minutes, 25 seconds into the flight, Discovery traveling 3,189 miles an hour. Its altitude 37 miles. Downrange from the Kennedy Space Center, 53 miles. Discovery now getting a boost into orbit from its twin orbital maneuvering system engines on either side of the shuttle's tail. These two engines will burn for 2 minutes and 32 seconds.
Your two-engine TAL. We do have updates to your no-com mode boundaries, and we did launch late into pane 1, our only pane. The contingency aboard boundaries we'll use are in-plane plus 230. Let me know when you're ready to copy the new Presta ATO and Presta MECO.
Okay, copy all. Two-engine TAL and ready to copy.
Into your Presta ATO 11.9. Presta MECO 15.4.
11.9 and 15.4.
That's a good readback on both.
Discovery can now make it to emergency landing sites in Europe should one of the engines fail, but all three engines continue to perform as expected. Capcom Charlie Hoba updating the crew there with some updated time information due to the later than planned launch. 3 minutes and 50 seconds into the flight, the shuttle traveling 4,700 miles an hour.
Discovery, you are negative return.
Negative return.
Discovery now traveling too high and too fast to return to the Kennedy Space Center in the event of an engine failure. But all three main engines continue to function as expected. The shuttle now traveling 5,200 miles an hour. Its altitude 62 miles, downrange from the Kennedy Space Center, 170 miles. Four minutes, 45 seconds into the flight, Discovery traveling 6,200 miles an hour. Its altitude 66 miles. Downrange from KSC 229 miles. Here inside Mission Control, Flight Director Richard Jones and his team continue to monitor the progress of Discovery's flight. All systems are continuing to perform as expected.
Discovery, you are Presta ATO.
Presta ATO.
That call from Capcom Charlie Hoba indicating that Discovery has enough energy to make it to a lower than planned orbit should one engine fail at this point. However, all three engines continue to burn as expected.
Discovery, you are single engine ops 3.
Single engine ops 3.
Discovery's engines are now swiveling to roll the shuttle to a heads-up position to get better communication with NASA's tracking satellites.
Discovery, your single engine Zaragoza 104.
Single engine Zaragoza 104.
Discovery can now make it to emergency landing sites in Europe should two engines fail at this point, but the flight continues to go well. 6 minutes, 24 seconds into the flight, the shuttle traveling 9,800 miles an hour. Its altitude 67 miles, downrange from the Kennedy Space Center, 447 miles.
MECO, BIM for you, nominal shutdown on all three, and Pinto, you'll be go for the plus X and go for the pitch.
Presta MECO, nominal shutdown, go for the plus X, go for the pitch.
Good readback.
That call from Capcom Charlie Hoba indicating that Commander Steve Lindsay has to go to press to main engine cutoff as expected in about a minute and a half.
Discovery, you are single engine press.
Single engine press.
Seven minutes, 15 seconds into Discovery's flight. The shuttle traveling 12,700 miles an hour. Its altitude 66 miles. Downrange from the Kennedy Space Center, 615 miles. Discovery's engines now throttling back to keep the forces on the crew and the shuttle to 3 times that of gravity. The shuttle traveling 14,000 miles an hour. Less than 30 seconds to go in Discovery's powered flight. We're coming up on main engine cutoff. Main engine cutoff confirmed. Space Shuttle Discovery now in space. External tank separation confirmed. Commander Steve Lindsay will steer the shuttle up to the forward portion of the external tank so that the umbilical well camera can capture some images of it.
Discovery, we saw nominal MECO, ohms 1 not required, preliminary TIG for ohms 2, 3730. Discovery, just a heads up, we are clean on all systems. We're not tracking anything out of the norm. For your post ohms 1, the only exception will be tail-only control not required, and that's probably what you're used to. Other than that, you can perform all actions as written, and we're still waiting on a go from Max for APU-hide shutdown.
Okay, we copy all that. Tail-only control not required. Everything else is written.
Good readback.
Die US-Raumfähre Discovery, wir haben es eben live erlebt, ist vor wenigen Minuten auf ihre letzte Reise gegangen. Um Punkt 22:53 Uhr deutscher Zeit ist das Shuttle vom Weltraumbahnhof Cape Canaveral gestartet. Bei besten Wetterverhältnissen gelang nach vielen Pannen und 4 Monaten Verzögerung ein perfekter Start. Auf ihrem Abschiedsflug wird die Discovery 11 Tage im All bleiben. Mit an Bord sind 6 Astronauten, die einen Roboter zur Raumstation ISS bringen. Danach geht die Raumfähre nach 30 Jahren im Einsatz in Rente. Und am Telefon begrüße ich Friedhelm Klaassen. Er ist Raumfahrtexperte der Deutschen Luft- und Raumfahrtgesellschaft. Herr Klaassen, nach der Discovery werden Endeavour und Atlantis noch einmal starten, aber dann ist Schluss. Was heißt das für die US-Raumfahrt und die internationale Raumfahrt insgesamt?
Ja, guten Abend nach Köln. Das heißt natürlich, dass die USA sich kümmern müssen, dass sie bald wieder in der bemannten Raumfahrt mitspielen. Allerdings muss man auch sagen, dass die ISS-Partnerschaft so stark ist, dieses Problem jetzt die nächsten Jahre zu lösen. Die amerikanischen Astronauten, auch die europäischen Astronauten fliegen derzeit mit russischen Raumschiffen zur ISS. Das sind diese Soyuz-Kapseln, die auch permanent an der ISS angedockt sind, die auch als Rettungskapsel dienen. Es wird also auf jeden Fall weitergehen, wenn auch nicht mit dem Shuttle-System, so mit neuen Systemen, deren Entwicklung jetzt schon vorbereitet wird. Und
vielen Dank,
Friedhelm. Wir haben eben auch die Abtrennung des externen Tanks gesehen, sodass die Mission also wirklich bisher wunderbar verlaufen ist.
Ja, danke, den Satz sollten Sie natürlich noch bekommen. Dankeschön. Friedhelm Klaassen war das Raumfahrtexperte der Deutschen Luft- und Raumfahrtgesellschaft.
20 seconds. The sound suppression water system has been activated, protecting Discovery and the launch pad from acoustical energy waves. Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's Space Shuttle team. The shuttle has cleared the tower.
Mission Control Houston, the Space Shuttle now rolling over onto its back for the 8.5-minute ride into orbit. Discovery now making one last reach for the stars. Throttling down as the orbiter passes through the area of maximum pressure, reducing the stress on the shuttle as it goes supersonic.
Discovery Houston, you are go at throttle up.
Commander Steve Lindsay acknowledging the call from Capcom Charlie Hobaugh as Discovery's 3 main engines throttle back up. Lindsay is joined on the flight deck by pilot Eric Bowen, mission specialist Al Drew, and Nicole Stott. Mission specialist Mike Barrett and Steve Bowen. Discovery's 3 main engines are burning fuel at a rate that would drain an average swimming pool in about 25 seconds. The engines, combined with the solid rocket boosters, produce more than 7 million pounds of thrust. 1 minute, 50 seconds into the flight, we're standing by for separation of the twin solid rocket boosters. Discovery now traveling 2,695 miles an hour. Its altitude 24 miles. Downrange from the Kennedy Space Center, 29 miles. Booster separation confirmed. Discovery's guidance is now converging as the shuttle's onboard computers fine-tune the flight. Two minutes, 25 seconds into the flight, Discovery traveling 3,189 miles an hour. Its altitude 37 miles. Downrange from the Kennedy Space Center, 53 miles.
activated, protecting Discovery and the launch pad from acoustical energy waves. Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's Space Shuttle team. The shuttle has cleared the tower.
This is Mission Control Houston. The Space Shuttle now rolling over onto its back with a 7-minute ride into orbit. Discovery now making one last reach for the stars. Throttling down as the orbiter passes through the area of maximum pressure, reducing the stress on the shuttle as it goes supersonic.
Discovery Houston, you are go at throttle up.
Commander Steve Lindsay acknowledging the call from Capcom Charlie Hobart as Discovery's 3 main engines throttle back up. Lindsay is joined on the flight deck by pilot Eric Bowen, mission specialist Al Drew, and Nicole Stott. Mission specialist Mike Barrett and Steve Bowen. Discovery's 3 main engines are burning fuel at a rate that would drain an average swimming pool in about 25 seconds. The engines, combined with the solid rocket boosters, produce more than 7 million pounds of thrust. 1 minute, 50 seconds into the flight, we're standing by for separation of the twin solid rocket boosters. Discovery now traveling 2,695 miles an hour. Its altitude 24 miles. Downrange from the Kennedy Space Center, 29 miles. Booster separation confirmed. Discovery's guidance is now converging as the shuttle's onboard computers fine-tune the flight. Two minutes, 25 seconds into the flight, Discovery traveling 3,189 miles an hour. Its altitude 37 miles. Downrange from the Kennedy Space Center, 53 miles.
All systems are go. About 90 seconds away from the launch of Space Shuttle Discovery on her final mission. T-minus 1 minute, 10 seconds and counting. The liquid hydrogen tank inside the external tank is now at the proper flight pressure. T-minus 1 minute and counting. The ground launch sequencer will verify that the 3 main engines are ready to start. The booster joint heaters are being deactivated at this time. T-minus 48 seconds and we're transferring to orbiter internal power. Discovery is now running on its 3 onboard fuel cells. Coming up on a go for auto sequence start at T-minus 31 seconds.
GLS is go for auto sequence start.
And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. 20 seconds. The sound suppression water system
15.
has been activated, protecting Discovery and the launch pad from acoustical energy waves.
GLS is go for main engine.
Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's Space Shuttle team. The shuttle has cleared the tower.
Mission Control Houston, the Space Shuttle now rolling over onto its back for the 8.5-minute ride into orbit. Discovery now making one last reach for the stars. Throttling down as the orbiter passes through the area of maximum pressure, reducing the stress on the shuttle as it goes supersonic.
Discovery Houston, you are go at throttle up.
Commander Steve Lindsay acknowledging the call from Capcom Charlie Hobaugh as Discovery's 3 main engines throttle back up. Lindsay is joined on the flight deck by pilot Eric Bowen, mission specialist Al Drew, and Nicole Stott. Mission specialist Mike Barrett and Steve Bowen. Discovery's 3 main engines are burning fuel at a rate that would drain an average swimming pool in about 25 seconds. The engines, combined with the solid rocket boosters, produce more than 7 million pounds of thrust. 1 minute, 50 seconds into the flight, we're standing by for separation of the twin solid rocket boosters. Discovery now traveling 2,695 miles an hour. Its altitude 24 miles. Downrange from the Kennedy Space Center, 29 miles. Booster separation confirmed. Discovery's guidance is now converging as the shuttle's onboard computers fine-tune the flight. Two minutes, 25 seconds into the flight, Discovery traveling 3,189 miles an hour. Its altitude 37 miles. Downrange from the Kennedy Space Center, 53 miles. Discovery now getting a boost into orbit from its twin orbital maneuvering system engines on either side of the shuttle's tail. These 2 engines will burn for 2 minutes and 32 seconds.
Your 2-engine TAL. We do have updates to your no-com mode boundaries, and we did launch late into pane 1, our only pane. The contingency aboard boundaries we'll use are in-plane plus 230. Let me know when you're ready to copy the new Presta ATO and Presta MECO.
Okay, copy all. 2-engine TAL and ready to copy.
Into your Presta ATO 11.9. Presta MECO 15.4.
11.9 and 15.4.
That's a good read back on both.
Discovery can now make it to emergency landing sites in Europe should one of the engines fail, but all three engines continue to perform as expected. Capcom Charlie Hoba updating the crew there with some updated time information due to the later than planned launch. 3 minutes and 50 seconds into the flight, the shuttle traveling 4,700 miles an hour.
Discovery, you are negative return.
Negative return.
Discovery now traveling too high and too fast to return to the Kennedy Space Center in the event of an engine failure. But all three main engines continue to function as expected. The shuttle now traveling 5,200 miles an hour. Its altitude 62 miles, downrange from the Kennedy Space Center 170 miles. Four minutes, 45 seconds into the flight. Discovery traveling 6,200 miles an hour. Its altitude 66 miles. Downrange from KSC 229 miles. Here inside Mission Control, Flight Director Richard Jones and his team continue to monitor the progress of Discovery's flight. All systems are continuing to perform as expected.
Discovery, you are pressed to ATO.
Pressed ATO.
That call from Capcom Charlie Hoba indicating that Discovery has enough energy to make it to a lower than planned orbit should one engine fail at this point. However, all three engines continue to burn as expected.
Discovery, you are single engine ops 3.
Single engine ops 3.
Discovery's engines are now swiveling to roll the shuttle to a heads-up position to get better communication with NASA's tracking satellites.
Discovery, your single engine Zaragoza 104.
Single engine Zaragoza 104.
Discovery can now make it to emergency landing sites in Europe should two engines fail at this point, but the flight continues to go well. 6 minutes, 24 seconds into the flight, the shuttle traveling 9,800 miles an hour. Its altitude 67 miles, downrange from the Kennedy Space Center 447 miles.
Miko, BIM for you, nominal shutdown on all three, and Pinto, you'll be go for the plus X and go for the pitch.
Press to Miko, nominal shutdown, go for the plus X, go for the pitch.
Good readback.
That call from Capcom Charlie Hoba indicating that Commander Steve Lindsay has to go to press to main engine cutoff as expected in about a minute and a half.
Discovery, you are single engine press.
Single engine press.
Seven minutes, 15 seconds into Discovery's flight. The shuttle traveling 12,700 miles an hour. Its altitude 66 miles. Downrange from the Kennedy Space Center 615 miles. Discovery's engines now throttling back to keep the forces on the crew and the shuttle to 3 times that of gravity. The shuttle traveling 14,000 miles an hour. Less than 30 seconds to go in Discovery's powered flight. We're coming up on main engine cutoff. Main engine cutoff confirmed. Space Shuttle Discovery now in space. External tank separation confirmed. Commander Steve Lindsay will steer the shuttle up to the forward portion of the external tank so that the umbilical well camera can capture some images of it.
Discovery, we saw nominal MECO, OMS 1 not required, preliminary TIG for OMS 2 3730. Welcome to you and your veteran crew back to space.
Copy, no OMS 1 required, 3730 preliminary TIG, and thanks a lot. Good to be here.
Good deal, Pinto. We'll meet you in the post-OMS 1 tab.
Yeah, that's where we're headed.
As we take a live look inside the shuttle flight control room here at the Johnson Space Center, we want to welcome you to NASA Television's live coverage of Discovery's final flight. We will have round-the-clock coverage throughout the entire mission, and of course you can always follow along on the NASA website at nasa.gov. At this point in Discovery's flight, Mike Barrett and Al Drew are in the process of unstrapping themselves to climb up to the windows of the flight deck. Barrett will be using a camera to capture some still photography of the external tank, and now Drew will be getting some video of that tank as it drifts away from the shuttle. This will allow the teams here on the ground to take a look at the foam on the tank to ensure that it fared well during today's launch. Those images will be downlinked to the teams here in Houston, and they will immediately begin to take a look at them. As we mentioned earlier today, this ascent team here is under the direction of Flight Director Richard Jones. This was his 4th ascent.
This camera view is from inside the payload bay at the forward end of the payload bay on the port side. It's known as Camera A. The orbiter docking system is in the lower left-hand corner of the frame. As we see first the starboard side of payload bay doors swinging open. Beyond the orbiter docking system that's in the lower left-hand side of our frame, if you look aft in the payload bay, you see the other payloads, including the Express Logistics Carrier, and then beyond it, the Permanent Multi-Purpose Module, formerly known as the Multi-Purpose Logistics Module Leonardo. As the portside payload bay doors open, you can see just a bit of the Space Shuttle's robotic arm there in the lower right-hand corner of the frame, heading back toward the left side OMS pod and the vertical stabilizer of Shuttle Discovery. Payload bay doors opened at 5:27 Central Time this afternoon as Discovery was flying above the state of Texas.
Then we see a good cryoconfig. Thank you.
Copy that. Thank you.
And Bim, can you also tell us, we may have missed it with all of our dropouts earlier, but if you guys are finished with the payload bay floodlights, can you confirm that they have been turned off?
They have not been turned off yet. We can turn them off now if you're ready for that.
We're ready, but it's whenever you're completed with them.
Copy. Taking them off now.
And just like that, the floodlights on board Discovery in the payload bay turned off as the crew gets their spaceship in the proper configuration for the overnight period while they sleep. The floodlights turned on in order to conserve the cryogenic components that are used to generate power on board the station. The light that we do see in this view is coming from an imminent sunrise. Discovery is now 143 miles above the southern end of Africa, just north of Johannesburg. And as we can see, just moments away from an orbital sunrise as they fly over the Indian Ocean.
Pünktlich kurz vor 23 Uhr unserer Zeit startete das Space Shuttle Discovery nach fast 30 Dienstjahren zu seiner letzten Reise. Denn das gesamte US-Shuttle-Programm wird eingestellt, zu teuer und zu gefährlich. Auf dem Weg zur internationalen Raumstation ist neben der 6-köpfigen Besatzung auch der erste menschenähnliche Roboter. 11 Tage dauert dieser Abschiedsflug der Discovery. Und es war viel los im All heute. Schon am Nachmittag dockte der europäische Raumfrachter Johannes Kepler an der ISS an, mit tonnenweise Lebensmitteln, Ersatzteilen und wissenschaftlichem Gerät an Bord. Auf dem Rückflug soll der Transporter dann vollgepackt mit Müll über dem Südpazifik verglühen.
Discovery, gerade eben ist sie abgezischt zu ihrem letzten Flug ins All. Die dienstälteste amerikanische Raumfähre. Sie bringt noch eine letzte Lieferung zur Raumstation ISS, dann wird sie in Ehren ausgemustert. Und die beiden Partnerfähren, also Endeavour und Atlantis, die sollen auch nur noch jeweils einmal starten. Danach ist Schluss mit dem gesamten Space Shuttle-Programm. Zu teuer. Jetzt fliegen also im Moment 5 Astronauten durch das Weltall, eine Astronautin und ein Robonaut als 7. Mitarbeiter. Der soll ein neues Zeitalter in der Raumfahrt einläuten.
We have main engine start. 2, 1. Booster ignition.
Ende des Countdowns und der Mann im Kontrollzentrum will seinen Stolz nicht verbergen. Unsere Anerkennung für die harte Arbeit des amerikanischen Space Shuttle Teams. Ein Bilderbuchstart in Cape Canaveral. Auf die Sekunde genau zum geplanten Starttermin macht sich die Discovery auf den Weg ins All. Zum allerletzten Mal. Mit an Bord sind 6 Astronauten und der Herr im weißen Oberteil, der hier so freundlich seine Erfinder begrüßt. Robonaut 2 haben die Weltraumtüftler der NASA ihr neuestes Spielzeug genannt. Er soll zum treuen Helfer in unendlichen Weiten werden und überall, wo es nötig wird, auch selbst Hand anlegen. Zunächst wollen die Astronauten testen, wie sich der Roboter in der Schwerelosigkeit steuern lässt. Später könnte er dann seine Fingerfertigkeit beweisen. Er soll reparieren, putzen und im Ernstfall Feuer löschen. In den vergangenen Wochen haben die Techniker ihn trainiert. Sein Einsatzgewicht 150 Kilogramm, nur Beine hat er nicht. Er ist wirklich einer der besten ferngesteuerten Roboter. Wir haben oft bis spät in die Nacht getüftelt. Irgendwann um 2 Uhr morgens haben wir uns mal einen Spaß mit dem Roboter gemacht und ihm eine Kung-Fu-Technik einprogrammiert. In dieser etwas ungemütlichen Transportposition hat der Robonaut den Start erlebt, in einer Kiste, die ihn vor den heftigen Vibrationen schützen sollte. Und hier wird er seinen Dienst antreten auf der internationalen Raumstation ISS. Die Discovery bringt das letzte wichtige Labor, außerdem ein Ersatzteillager. Die NASA will die ISS noch besser bestücken, bevor die Raumfähren im Sommer ihren Dienst einstellen. Nach dieser Mission sind nur noch 2 weitere Space-Shuttle-Flüge geplant. Künftig bedienen nur noch Russland, Europa und Japan die Strecke zur ISS. 11 Tage wird die Discovery im All bleiben. Danach landet sie endgültig im Museum.
2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work and pride of America.
Talk about a send-off. The Space Shuttle Discovery started its 39th and final mission on Thursday with a spectacular liftoff from Kennedy Space Center in Florida. Discovery is on its way to the International Space Station. In the coming months, NASA is planning final missions for the remaining pair of shuttles. Discovery is a record setter. It's carried 246 crew members over 26 years of service. That's more than any other spacecraft in history. John Zarrell has more on Discovery's final mission, which did not start without some last-minute drama.
The liftoff of the shuttle Discovery turned into somewhat of a cliffhanger here at the Kennedy Space Center. With just minutes to go before the launch, the countdown had to be stopped while NASA worked through a computer glitch. And it was only within seconds of when they would have had to scrub the launch for the day that the computer glitch was fixed and they were able to get Discovery off the ground against the background of a beautiful February sky.
And the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's space shuttle team. The shuttle has cleared the tower.
About 4 minutes into the flight of Discovery, you could see a piece of foam from the giant external tank coming off and hitting the bottom, the underbelly of the orbiter Discovery. But at that altitude, the atmosphere is so thin that it more than likely did not cause any of an issue, although certainly the NASA engineering teams will take a close look at that just to make sure. Now, once the Discovery and its 6-member crew rendezvous in 2 days with the International Space Station, they'll be bringing up what amounts to a giant closet where they can, that the International Space Station crews can use for storage of equipment. They're also bringing up Robonaut 2, a dexterous robot, the most sophisticated ever made. It's going to be tested in its ability to help astronauts with some of the tasks so that it can take over things like holding wrenches and holding hammers, maybe even turning some light bulbs. That would relieve the astronauts on the station of doing those kind of tasks so they can concentrate on things like working on science experiments and the like. So right now, Discovery on its way towards a rendezvous in 2 days with the International Space Station. On its 39th and final flight, it'll return here to the Kennedy Space Center in about 11 days. John Zarrell, CNN, at the Kennedy Space Center in Florida.
2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's space shuttle team.
For the Space Shuttle Discovery, this is the grand finale.
Discovery Houston, you are go at throttle up.
And it went off without a hitch. A perfect launch for one of the world's most accomplished spacecrafts. After almost 150 million miles, a total of a year spent in orbit, and 30 years of service, this is the final mission for Discovery, and it's a sentimental occasion for many at NASA.
You know, it's kind of bittersweet that we get the last flight out of her, but she's going to perform perfectly fine on orbit and bring the crew home safely.
Discovery is the oldest surviving shuttle in the fleet. It first launched back in 1984.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope.
And over 20 years ago, Discovery carried the Hubble telescope into space. Its enduring images have changed the way we look at the universe. And in the late 90s, Discovery took John Glenn, the first American to orbit the Earth, back into space at the age of 77. This latest mission is once again a visit to the International Space Station, where the crew will drop off its newest resident, a robot known as Robonaut 2. When Discovery returns to Earth next month, it will be decommissioned and sent to a museum. There are now only 2 more planned launches before the entire shuttle fleet is retired for good, the end of an era in space travel. Andy Gallagher, BBC News, Florida.